Morning, everyone. Yeah, well, welcome to today's class. I trust we had a great weekend. and by now we should all have crushed our previous assignments. Right. For those of us still having issues, 1 or 2 issues, you can always reach out. You can reach out to me, you can reach out to Abiola, that's Oracle, for assistance. Okay, so moving on to today's class, we'll be diving into Arbitrum, and we'll be taking a look at Arbitrum SDK. Okay, so we have understood Arbitrum as a technology. We have also understood Arbitrum as a blockchain, right? So today we'll be looking at how to work with Arbitrum SDK. Yeah. So just a minute. Okay, so before we dive into today's class, can somebody just give us a recap of Arbitrum as a technology and Arbitrum as a blockchain? Don't if you cannot remember the specifics, just give us a brief understanding or explanation of Arbitrum itself. Okay. Okay. So can you be more audible so that people are like that?
It takes some security measures from
Okay.
it's also kind of facilitates our concept.
All right. Thank you. That was good. Aduwale, I saw you raise your hands up. Do you have something to say? So, you can unmute if you want to speak, Aduwale.
Can you hear me?
Yes, we can hear you.
Okay. I understand the Arbitrum as a blockchain because it is a layer 2 blockchain technology blockchain on Ethereum. I understand it as a technology because it offers different services like the I'm trying to remember the name of some of the technology, but that's how I understand it.
All right. Thank you very much. So by now we know understand that Arbitrum is a layer 2 technology, right? And layer 2 are built to optimize layer 1 technology, right? So there are solutions to layer 1 problems or issues. Now we also understand that Arbitrum uses the optimistic rollup right technique, and we know that how it performs transaction is these transactions are moved to the layer 2 where their transactions are done, and then once they are completed, they are now moved back to layer 1 through the optimistic rollup. So they are batched together and then moved back to layer 1. So now this SDK, generally when we talk about SDKs in programming languages, we should understand that SDKs are like libraries, or they're like libraries packages that can be used to connect to your applications, that can be used in applications in your softwares and all. So now Arbitrum has its own SDK. So it has its It has different functionalities. This is SDK. Can help you perform different functionalities, such as you can move assets, tokens from layer 1 to layer 2. And then there's also like the cross-chain messaging. So different functionalities that this particular Arbitrum SDK offers. So we'll be looking at them. And specifically today, we'll just get a broad overview of the functionalities and use cases, while tomorrow we'll look at how to bridge tokens using custom gateways. And then on Wednesday, which is going to be our final class, we'll be looking at L1 to L2 messaging, right, in Arbitrum. So let's dive into today's class and see. So the objective for today's class is we would learn Arbitrum SDK the features and its fundamental use cases. Now, what is Arbitrum SDK? It's a TypeScript library. TypeScript, we know TypeScript. I'm sure we know TypeScript by now. So it's a TypeScript library for client-side interactions with Arbitrum. It provides common helper functionality as well as access to the underlying smart contract interfaces. So using the Arbitrum SDK, you have access to different helper functionality. You also have access to different classes. You have access to underlying smart contract interface. So it's quite big and a lot, but we'll just look at a few of them that we have. So firstly, we'll be looking at bridging assets, right? So that's part of the functionalities of this Arbitrum SDK. Arbitrum SDK can be used to bridge assets to and from the rollup chain. These following asset bridgers are currently available. We have ETH bridger and then ERC20 bridger. So when we talk about bridge generally in the blockchain sense of things, we're talking about moving assets from a chain to another. So some of us that are used to crypto, that is moving crypto around, transferring crypto and the rest, I'm sure at some point you may reach a certain level where you have to bridge your assets. So that is, you're converting your asset from one chain to the other. So this time around, what's happening is in this Arbitrum SDK, it is used to bridge assets, that is, move assets to and from your roll-up chain. So that is from Ethereum itself to Arbitrum, right? And then Arbitrum back to Ethereum. So this is what bridging assets is. So now we have two that are currently available. We have the ETH bridger. So this is used to move ETHs itself. We want to move ETHs. No, ETHs is the native token for Ethereum and Arbitrum. And then we have ERC20 bridgers. So if you want to move tokens, right, you want to transfer token from probably Ethereum to Arbitrum, there's the ERC20 bridger. So for DTH bridger, we'll look at it today. We'll see how to move deposit token. We are using this ETH bridger. For ERC20 bridger, we'll dive into that tomorrow, right? So one thing you should we need to also understand that all asset bridgers have the following methods. Deposit. So this moves assets from the L1 to the L2. We have deposit estimate gas, which is used to estimate the gas required to do the deposit. We also have withdraw. So if you want to move your assets back to L1, you have the withdraw method. This moves assets from the L2 to the L1. And then we have withdraw estimate gas. This estimates the gas required to do the withdrawal, which accept different parameters depending on the asset bridger type. So all the asset bridgers, they all have these four common methods. Now, if you take a look at them individually, they can have more methods, but in terms of similarity, what common methods do they have? They have these four common methods. So if you actually still take a deep look at it, for example, for ETH bridger, it also has deposit too, which is if you want to send to a destination address, Then, so they all have individual methods that may be more than these four, but in terms of commonality, they make use of these four are found in both of them. Now we also have cross-chain messages. So when assets are moved by the L1 and L2 cross-chain messages, so when assets are moved by the L1 and L2, cross-chain messages are sent. The life cycles of these messages are encapsulated in the classes L1 to L2 message and L2 to L1 messages. So these objects, they are objects that are commonly created from the receipts of transactions that send cross-chain messages. The cross-chain message will eventually result in a transaction be executed on the destination chain, and these message classes provide the ability to wait for that finalizing transaction to occur. So we have cross-chain messages. They are usually involved when assets are moved from L1 to L2, L2 to L1. And then there are like the classes of L1 to L2. You want to get the message, there's a method you can use, which is L1 to L2 message. And then we also have L2 to L1 message, right? So all these are just like the brief overview. Maybe we'll dive fully into this on Wednesday, right? Which we're dealing with messaging. But we just need to understand that when assets are moved, cross-chain messages are also involved. They are sent, and they eventually result in a transaction be executed on the destination chain. So you can actually know when transactions are executed on the destination chain to return the success status for you. You can always get your status. You can know. There's also like the wait method, which you can wait for all the transactions to be confirmed, right? And then at that point, you know. So all of these are quite useful in the Arbitrum SDK, and then you trying to bridge. So even today, we would see how all of this work together. Would you make use of the weights when we're trying to confirm our L2 transaction? And then we also have networks. So Arbitrum SDK comes pre-configured for mainnet and testnet, and also the Arbitrum counterpart. However, this network functionality can be used to register networks for custom Arbitrum instances. Most of the classes in Arbitrum SDK depend on network objects, so this must be configured. So you must ensure that you configure your network while using the Arbitrum SDK, because they must be configured. If not, it's going to fail. And then lastly, we have retriable tickets. Now, these retriable tickets are Arbitrum's canonical methods. So they're like reliable, easy to use methods for creating L1 to L2 messages. So that is L1 transactions that initiate a message to be executed on L2. A retriable can be submitted for a fixed cost, which is dependent on its core data size, paid at L1. So the submission on L1 is asynchronous, which is execution on L2. So that is, you can get two different status for L1 and L2. They are synchronous, they are separable, like they're separate. So you can know when it has been executed on L2 and when it has been submitted on L1. So all of this, they are useful in everything we're going to do. All right, so do we have any question? Do you have any question? So in the absence of questions, I'm going to dive into yeah. Does it help? Yeah, so the Arbitrum has like its own So it uses Ethers. Then you can now create tokens on the Arbitrum network and then interact with those tokens. So you can deploy it on the L2, which is Arbitrum. So for example, if you have your normal Ethereum, right? You can deploy your tokens on Ethereum network, and your tokens you can now import such tokens. So, for example, let me just show you an example. So this is my MetaMask, right? If I come to Arbitrum Sepolia, this is a network. It's a network itself. And then underneath, I can see my balance, which is in Ethers. And then I can now import tokens to it. So can you see? I can import my token. So if you deploy on the Arbitrum Sepolia, you can, like, if you deploy your ERC20 token, you can always import this token to it and interact with it. I didn't get you.
You actually import Arbitrum.
Okay. Yeah, both Arbitrum and Ethereum makes use of Ethers. So that's how it's works. All right. So we would move into the practical session. So we'll be making use of ADATs. We'll also make use of Ethers. And we'll also install our Arbitrum SDK. So firstly, before we do that, okay, now let's go ahead to start our class. So I'm going to initialize a new project. This is good enough. All right. So I will initialize a new project. I'll call it the desktop. So I'll just create a new folder in my desktop, and then I can name this probably Arbitrum SDK Bootcamp 2022. So I've created the folder. I will just I will navigate to the folder. Please hope we are all familiar with command line. So it doesn't look like we're doing magic here. So to just go through everything, I navigated to my desktop folder using CD. I created a new folder, that is a directory, and then I named it Arbitrum SDK Training, and then I navigated into that folder. So now to initialize the project, I'm going to use npm init. This to initialize a project. So yeah, so I'm getting it to walk me through. So what's required for me at this point is to give it a name, package name. I'm just going to name this Arbitrum, the same name of the folder, the version, the description. I'll just put a quick description to show how to deposit to L2. Right, from L1 to L2. All right. So the entry point is the object, test command of this, and then we can say. That's interesting. Please can you see my screen now? Those of us online. Those of us online, can you see my screen? All right. So to continue. So I was just initializing a new project using npm. So I'm just filling in all of this. All of this or not. Okay. All right. So we have created a new project which we have initialized with npm. So I'll just go ahead to import that to my code editor. So I'll open this onto desktop. All right. So when I open it up, you'll see I just have package addressing. From here, we can build our project. We can build it up. So the first thing is we need ADAT, right? And ITAS. Since we'll be executing, we'll be dealing with our Arbitrum SDK. And then we also need to install our Arbitrum SDK itself. So so the next thing we would be doing is just run some of the installation commands. So to install Arbitrum, the Arbitrum SDK, we do npm install Arbitrum/SDK. So we also we'll be making use of an env file. And since we are making use of we need to install .env, the package, right? So we could actually make use of our env file. So I would install .env too. Then other ITAs, we can install those as dev dependency. Last class, I explained to us what dev dependencies are. So I would I'll go ahead to install them as dev dependencies. So to install dev dependencies, you use what -save -dev, right? So we would make use of only clouds ITAS. We also install ITAS itself, and then also install ADAT. Yeah. So we're installing 3 packages at once: ITAS, ADAT, and Nomic Labs ADAT ITAS, which is the package for us. All right, so our packages have installed, and then check our package addressing. We'll see. Sorry, I forgot to add dash dash. Forgot to install them as dev dependencies. Yeah. So for our dependencies, we have Arbitrum SDK, and then we also have .env. For our dev dependencies, we have this, and our node modulus folder has been generated for us automatically. So at this point, we have the necessary libraries and packages required to move on to the next thing. Now, we also know that to configure our ADAT, we need the config. We need a config file. So to do that, we just use adat.config.js, which at this point we should all know that ADAT has this option. So now for this ADAT, we'll be making use of this ADAT ITAS package that we installed. So it's just like adding extra configuration for us. And to make use of that, you use like the require keyword, and then we just require this. All right. So all of our adapts will be configuring. And instead of this, we'll configure both L1 and L2. Okay, good. So for L2 and L1, they have common configuration, which is URL. So to pass in the URL, which is supposed to be a string. And then for L1, we can pass gas limits 0, and then we can also pass gas price and make this auto. All right. What else? Okay. I think we also need to pass in adapt itself in the configuration. Just in here, we'll pass gas as auto. Change this to gas. All right. Now, this is how our config is going to look like for our adapt, where we are trying to configure the networks. And remember, we're going to deal with two networks, the L1 network and the L2 network. So we are passing in the necessary configurations for both networks. For L1, we are passing in the gas limit and also the gas, right? So just like just passing in the maximum gas price. And then also we have to pass in the URL. Now this URL, we are going to be using Euphoria provider. So remember, we have different types of providers. We have Web3 provider, we have Alchemy provider. So in install, that's installing in interacting with ADAT and even ETAS, we can always provide different URLs. And yeah. So what we'll be doing is for URL, we'll be making use of Euphoria. So how do we make use of Euphoria? So you just come to Euphoria, you can just search for it on Google. The first result that you get, and then you can get started. So it will require you to register and get an API key. So you can always do that. But I have an account, so I'll just go ahead to log into my account. Right. So to active for your application category, you can just put something like I'm here to learn. Or you can just do it later. All right. So you can always, so once you come here, it will land you on the API keys page. You can go ahead to create a key for it. So me myself already have a key. So I'll just go ahead to copy the key. Now let's note something. It will require you to activate the endpoints, right? So you are going to see a list of networks. Let's pay attention. So you see a list of networks, and depending on the network you want to work on, you need to activate it. So if you are working with Ethereum as your L1, you need to activate the endpoints. If you're going to use mainnet, Sepolia, or Grioli, you need to activate them for them to work. If not, they won't work. So let's take note of that whenever we create our API key. So I would copy this and then go back to our project. So what I'm going to just name this I'll create a new env file first. So I'll create a new env file and then I'll name this L1, probably RPC. Yeah, so let's name this L1 RPC. So since we'll be working on the Sepolia network, what I would do is you can always get right. So you can come back to active network, and depending on what you want to work on, like if you want to make use of Ethereum Gorilla, you copy this URL. You want to make use of mainnet, you copy this URL. You want to make use of Arbitrum Sepolia, you copy this URL. So since I'm going to make use of Ethereum Sepolia, I would copy this URL, which is sepolia.ethereum.io. Now I'm going to use that as my provider URL. Do we understand? So coming back to our config, in here as the URL, what I would do is I would pass in process.env, and then I would use RPC URL. Right. So remember from our last class, I said you can always do a optional, you can pass in a string in case it's undefined. So now we have that. For our L2 URL, we don't need the key. All you just need is just the network. So what we would pass in for that is we'll just find the Arbitrum instead of our env file. We'll do so. Let me go. All right. So we have so we're making use of this Sepolia rollup Arbitrum, right? That is the Arbitrum Sepolia network for our L2. So this is the network we're using for our L2. The URL. So it's kind of constant. So it's something that to apply for every time you want to import the Arbitrum Sepolia URL. So I can easily just drop that on maybe the WhatsApp group. Right. So it doesn't anytime you want to make use of Arbitrum Sepolia RPC, you would make use of this URL. But for L1, this can always change. Your key can change. If you are using a different network, this Sepolia is going to change to the network you're going to use. So now we have this. So I'll just come in here and then do process.env.l2 RPC. All right. So we have this set up already. Okay. Huh? Okay, without the process.env. Oh, we can do that. You can import dot. That's the. Oh, okay. Let's try that. So dot config, right? Like this. Right. Okay. So we have this. Now, for L1, we also need to pass in the account. That is the account where we want to interact from. So an easy way to pass in the account is, now we can easily get we can create a new variable and then just name this private key. So now we're going to use our wallet private key. So I'll copy this and then use private key, right? So I'll check if is assistant. If it's assistant, we use this and then we use an empty array. Remember, accounts usually passed in use array to pass in the value of accounts. All right. So this is all for our configuration. So we'll move into our script file. Huh? So once this, remember we are passing in this. So once it fetches this, you will see that the chain ID is also returned. So it returns everything about the network. Once it fetches that, you chain ID, name, everything that is required about network. So everything is going to be passed inside of this RPC. So I created a script folder, and then inside of the script folder, I'm just going to name this exec. So this is where our execution is going to take place, and everything that is required. So let's check online if there's anybody. All right, so I think we are good to go. So in here, we would make use of ITAS. We would also make use of our ELV files, our ELV, right, our variables, and also we will make use of the Arbitrum SDK itself. So this is where we're going to learn how to deposit ITAS from L1 to L2, that is from Ethereum to Arbitrum. So how do we do that? So first off, we need to import our provider because we need to initialize or instantiate our wallet and providers. So I would get that from ITAS, which is require ITAS. So this requires just like your import statement, but this time around it doesn't require. You want to make use of import, the additional configurations you need to do, where you need to change your type to module in package or JSON. But to avoid all of that and to save our time, we'll just make use of require. So we're going to import our providers firstly, and then we also import our wallet. And that's because we want to instantiate a new wallet. And then, so let's go ahead to set up our provider. So we're going to set up two providers. One is going to be for our L1, and then the second one is going to be for our L2. So for our L1, we'll just name this L1 provider. And we can now do new providers. So use JSON. And then for the second one, we use L2 provider. Now, for L1 provider, we are going to make use of this variable, which is L1 RPC. So we're going to instantiate this with this. So firstly, we need to import our .env also here, right? So we use require .env.config. So this is we because our .env file. So we are going to pass in our L1 RPC. And then for L2 provider, we are going to pass in L2 RPC. So we have two providers, one for L1 and second one is going to be for L2, our Arbitrum, which is our Arbitrum in this case. So Now, since the transaction is going to be happening from our L1, we are trying to deposit from L1 to L2. So it means we need to have access to the account where we want to send from. And to do that, we would instantiate a new wallet for L1. Now, this wallet is a class, so instantiate this. So now this takes two parameters, which is what? Firstly, we need the private key, as you can see here, and then we need the provider. So I would just create a new variable, which is cost L1 private key. Go to, so I'll get this from here. So this is going to be our private key. Go to pass our private key. And then for the provider, I'll pass in L1 provider. Right. We're trying to connect to our wallet, our L1 wallet. Okay. So what else is required? We need our destination address. Where are we sending the ethers to? And the amount to deposit. Where we need those two. So I'll just create a new variable and then maybe just instantiate this to a string, and then for amount to deposit. All right, so we have this setup already. Do you have any question about the setup so far? Any question on the setup? Yeah. All right, so now we would now go directly to our ADAT. So we would initialize our ADAT function. This is where everything is going to happen. So since we'll be doing it on the terminal, I would like us to keep track of what's happening. So I will just do console.log taxing process, right? We can do this so we can know what's happening at every point. Now there's this add default local network that comes from Arbitrum SDK itself. Add default network. So what this does is it registers a custom network, right, that matches the one created. So this is useful in development. So what it will do is to just get the default local network of which you have imported, right? And then it makes use of that for you. So now we'll be diving into how to deposit from the L1 to the L2. So firstly, what you need to do, so let's pay attention. Okay, so to just get the default local network from that is on the L2. So since we are initializing this wallet, right? So to just get the default network for you. Yeah. And then make use of that way. For both L1 and L2. So to return both L1 network for you and L2 network for you. Okay, moving on. We need to get the L2 network itself. So we need to like fetch everything about the network, and then from there now activate. So remember I said the chain ID, everything is going to be included inside of that RPC URL, and then it can fetch that. So how do we do that? What you do is So there's also this method, which is we can use get L2 network, right? And then you now pass in the provider, L2 provider. So what this will do, it will fetch the network for you. So to return, so if you over on this, you see what it returns the Arbitrum chain associated with the given signer. So meaning this L2 provider, it would fetch the RPC and then return the chain, right? So it's going to fetch everything about that provider and then return the associated Arbitrum chain for you. So we can just initialize this to, you can just give this a variable name. So we can name this L2 network, right? Yeah. It's going to fetch the network for you. So remember, for L2, we're using Sepolia. So it's going to fetch everything about Arbitrum Sepolia for you. And then return the chain, the Arbitrum chain. Now, from this network that you have fetched, you can now, remember we said there's the ETH bridger, and then there's ERC20 bridger. ETH bridger is used when you want to move ethers, right? So what you are now going to do is you will now call that ETH, since we want to move the ETH bridger. So you will call this and then pass in this network that you have fetched to it. They're going to pass in the L2 network to it. Do we get? So we can also give this a variable name of ETH bridger, right? Bridger. So we have done two things inside of our which is we are trying to get the L2 network, and then we are now instantiating our bridger with the L2 network that we have gotten. Do we get? So now that we have assigned this to a variable, you can now do different tasks, you can have different functionalities from this ETH bridger that you have. For example, I can call this, and then if I do dot, you can see I can get the L1 network. So let me zoom out. So I can get the L1 network, I can get deposit to get approved gas token request, get deposit request. So you have so many options, methods that you have access to. And remember, we're trying to deposit from L1 to L2. So we'll be making use of the deposit to method, right? We'll be making use of the deposit to method. Now, this method takes in params, right? And what param does it take in? Now, it takes in different, so inside of your object, you have to pass in different params to it. Firstly, you have to pass in the amount. So how much are you sending? So the reason why we're using deposit to, just remember, is because we are trying to send to another address, to destination address. So that's what we're using deposit to. So we have the amount. Now this amount, remember, if you want to pass an amount, you do have to pass ethers. And can get that from ethers library. Pass ethers because to require, right? So you can get this from ethers library. But we can just, since we're already like importing ethers, we can easily import ethers and change this. So we don't import twice from the same library. Do we get? Those of us online, are we getting it? You can just, I should move on. Oh, okay. Let's pass ethers from ethers to so yeah, I will just do address to send L1 ethers to. L2 address. So amount to deposit is quite explanatory. So for this, transfer Ether from L1 to L2. So we use L2 network here to create an Arbitrum SDK jailbridge distance. All right. So we have the amount and the impasse Ether, which we get from our Ether's utility. So I'll just pass in this variable, which is amount to deposit. Now we have this. Now the next thing we need to do is you need to pass in your L1 and your L2. So for L1, you'll be passing in the signer. And what this will, so you just pass in the L1 wallet that we already created. So that's going to be your L1 signer. But for L2, all you just require is the provider. So you pass in the L2 provider. So do you get why we instantiated our wallet? And then for L2, we pass in the L2 provider. And then lastly, what is required is the destination address. Destination address. So I can leave it like this. Why? Because if the key and value, no, in JavaScript, if the key and value are the same, you can just pass it in as this. But for our newbies, let me just do it like this, so we don't get confused. We get, yeah? Do you understand? Okay, so this is what was necessary at this. So this is like all that's required. Every other thing you're going to be doing is just waiting for this to be done. I remember when we talked about retrievable tickets, we said it has the wait method, which returns after confirmation. Right. So we'll just go ahead to show how to do that. How do we do that? Now, this ETH bridger, right? Let's assign that to a variable. So I will just do the deposit transaction. And then it's a promise, so I'll use await. If you want to wait for this transaction to be done, for L1 confirmation, right? Remember, there's going to be L1 confirmation and then L2. We said they are separable. That is asynchronous. They can be. So for L1, all you just have to do is so you can just wait for deposit. You call this variable that you assigned it to. Dot. There's wait. L1. So this is us waiting for our L1 confirmation. Once it's done, let's console log our transaction hash. Right, so we do deposit L1 hash or receipt, right? You can just name it receipt. Let me make this a dynamic string. So now we can do deposit rec dot transaction hash. deposit reg dot transaction hash. If you want to wait for L2, how do we wait for L2? So with the L1, so with the transaction confirmed on L1, we now wait for L2 to be done. So I hope with this console logs and comments, they are becoming easier for us to understand. So we are done. We have assigned our deposit to a variable, and then we are waiting for the L1 confirmation. So for the transaction to be confirmed on L1, we wait for it. So once it's done, we'll get a console log with the transaction hash, that is the receipt. Okay, we are done. Once that's completed, we now want to wait for L2 to be executed, right? So how do we do that? So there's wait for L1. For L2, what you do is deposit transaction dot wait. So wait for L2. So now you now have access to wait for L2. But this wait for L2, you need to pass in the L2 provider. That's the difference. Hope we are saying how everything is linking up together. So what we are doing so far is, let me just go through everything again. We are getting our L2 network, we're fetching that. And then we use the L2 to create ETH bridge instance, right? And then from there, we now deposit. So we're depositing to that. And so while the deposit is going on, remember we're trying to deposit from L1 to L2. It's going to take it's going to take time. It's not straightforward, like you just click send and then it just goes straight up. It's going to take time for it to deposit. And that's because it needs to be confirmed on the L1, and then the L2 too needs to be executed. So for you to wait for it, you now have the wait method. So this wait now is you're telling it, okay, let's wait for L1 to be confirmed, right? For the transaction to be confirmed on the L1. And once that is done, you can now wait for L2. So we have dots wait for L2. So I'm waiting for L2 transaction to be executed. So once that is done, then you know your transaction is completed. So how do we know that transaction is completed? So you get so let's assign this to a variable. So we'll name this L2 result. Then this L2 result, we can now get complete. So once it's completed, this complete is going to be true. Right. So if complete is false, it means it's failed. So we can now console the log L2 message failed, right? Yeah. And then console the log L2 message successful. Remember, we talked about cross-chain messaging. Right. And for retriable tickets, what do we say? L1 transactions that initiate the message will be executed on L2. And so this is the message we are waiting for. So once it's completed, we console log L2 message successful. Or if it is false, then we know that it failed. So that's all that is required for us to deposit from L1 to L2. So I'll just go ahead to call our main. So we can just do a quick, maybe once it's completed, we should stop the process so it doesn't keep running. So do process.exit and then 0. If there's an error anywhere in our code, so just process.exit, right? Process.exit. Okay, so we're going to return 1. 1 is for failure, 0 is for success. So now we have all of this. How then do we run this code? So to run this code in our package.json, we just come to our scripts. And then inside of our script, we'll just name this exec. Let's just name this as you can give it any custom name that we want. So for this, we'll do add out run script / exec.js. Any question? Before we run our code and we'll see if it works. Okay, yeah, so I forgot something. The EMV, our private key. How do you get the private key? So you come to your wallet, your MetaMask wallet, or whatever wallet you want, and then let's use this address since I have token. Right. I'll come to Sepolia. So I should see, yeah. If we click the option, yeah, the private key. This is my test account, so it's for my test account. I'm not going to use it on mainnet, so I can always get rid of this. All right. I should use that instead, right? We can also do that. I'll just name this account 6. And then I just send to my account 6. So I'll send 08. All right. So I've sent this. We have 0.08. Let us quickly get my so for our destination address, let me just create a new account so we we see a. So I'm going to pass this as our destination address and then amount to deposit. So we can do 0.03. Right. Okay, so we have this. So to run our ADAT, this command, what do we do? So you just do your npm run exec. Remember in our package of JSON, we added exec script which will run our ADAT for us, right? So I'll go ahead to run this, but then it's failing. Why is it failing? So L1 RPC is not defined. It's not in our L1 RPC. Is that? Let me add my procedure technique right.
Why would you have string?
In cases not defined. If our process L1 RPC is not defined. So if I run this again, so instead of our exec file is failing too. So I'll just come back here and add process.env. What this also. So let me run this and then see. So I'm getting starting process. This works now. I don't know, maybe, but then it's failing. Starting process. That actually work with this Arbitrum SDK through the weekend and it worked. Fourth network. Still failing. It's quite interesting because Okay, so we're getting could not detect network. Could not detect network. I couldn't detect network. So let me check. Let me check. Hold on. Yeah, so it's working now. So at this point, we are waiting for L1 confirmation. So we can see waiting for L1 confirmation. So once this is done, we are going to see our transaction hash. That is done at this particular point. We can see deposit L1 hash received. This is our transaction hash. And then it's now waiting for the L2 side of the execution to be. So let's open up our Explorer. So I think there's not a Sepolia, not Abyss. So we'll use the L1 Explorer. Pascal. So let's search this transaction hash and see. We can see that this returns a result. And if you check the details, let me zoom in. We can see that we're trying to transfer from, this is our address where I send it to. And then two, we're trying to transfer this amount of Ether from our wallet to the address that we provided. And we can see the gas fee, we can see other details about the transaction. So coming back here, the L2 side of the transaction is yet to be executed. So that's why it's still loading. So this is why it's important that you wait. So you're waiting for it to be confirmed, the transaction to be executed. So once this is done, we'll see L2 message successful. So let's just wait. As we're waiting, is there any question? Are we lost?
Takes more time.
Can transfer back. So that you notice we said cross-chain messaging. So that it involves from L1 to L2 and L2 to L1. So you could always transfer. No roll-up involves you transferring the assets from your layer one solution to your layer two, and then they're now bundled up and sent back to your layer one. So yeah, it goes both ways. You can send to you, then you can send back to and fro. Exchange. Yeah, so it depends on what you need per se. So for exchanges, most of them do within the same network, right? But in scenarios where you want to bridge, this is where you can make use of this. So there are actually some of these exchanges that allows you to bridge. You see bridge asset or bridge token or something. So to allow you to convert from a network to another. So in this scenario, it's going to be from Ethereum to Arbitrum. So tomorrow we'll be looking at how to bridge from bridge tokens from Ethereum to Arbitrum. So Arbitrum token. So we still have to move tokens and all. All right, so this is still loading up. We have to keep waiting. Huh? When is it? I think it's supposed to be a class tomorrow. I don't know. We'll get back to you on that. It's taking quite some time. Those of us online, do you have any question? Dewale, Manuel, Esther, Belumi, Adelu, Malariwa. Do we have any question? Think I'll close this. All right, so it's done. We got L2 message successful. So how do we confirm that we sent from Ethereum Sepolia to Arbitrum Sepolia? So if I come here and then go to my new account. So let me switch network to Arbitrum Sepolia. So I'm seeing the 0.03 that I transferred from Ethereum. How much did I transfer again? 0.03. I come here and then for the new account, I can see the 0.03 that I transferred. So you can see I transferred from another network, from Ethereum L1 to our L2. Do you think it's simple? Over 10. How would you rate? How would you rate it? Is it simple? Is it tricky? Is it straightforward? Yeah. I think Arbitrum has their bridge site, right? But then not just dealing with Arbitrum. If you want to continue like in the blockchain world also, even if you want to create your L2 solution, you need to bridge assets. And is quite a good knowledge understanding if you know how to bridge assets from your code. So this is just showing you. So if you, for some of us that will be participating in the hackathon and then want to learn how to bridge, okay, because some people may want to bridge such tokens from another network to Arbitrum, from Ethereum to Arbitrum. This is how to go about it. Yeah, it's quite straightforward. This is actually simple. Tomorrow may be more tricky because longer. Yeah, it's supposed to be for 3 hours. So we can see that that we have reached successfully. So it's just at this point, I actually feel we should be conversant with ADAT configuration. So you just have to do your ADAT configuration. And then you just know that you need to you need your two providers, one for your L1 and the other one is going to be for your L2. Your L1 is also going to require a wallet. And then once you have that, you now instantiate your bridger. So for the slide, we said there are two types of bridger in Arbitrum. There's the ETH bridger and ERC20 bridger. ETH bridger is for Ether, like you want to transfer Ether. And then ERC20 is for transferring tokens. So you just need to understand. And then once you do that, all that is left is to do your deposits. And once you have done your deposit, you wait for it to be done. And then that's all. It's something that in 5 steps or so, you could be done with everything about it. All right. Any other question before we end the class? Any other question? So let's take note of this because this flow is what to be using tomorrow. be using minus down. Oh, so let's take note of this flow. So we'll be ending the class now. Thank you for joining. We can always go through the video over and over again. If there are questions, you can always ask on the group, or you can always message me or Oracle. All right. So take care. See you tomorrow. All right.